We're going to hear now from FiberX, telling us about a novel lignin-first biorefinery that solves biomass upscaling challenges. We have Dave Skibinski, who is their CEO. Dave, please.
Good afternoon, and thanks for staying. I guess I'm the second to last presentation before you get to go home, so it's you are the stalwarts of the conversation. I'd like to say I'm Dave Skibinski. I'm a co-founder of FiberX. I'm proud to represent the state of Indiana in bioinnovation in our state. Agronovis and Heartland Bioworks helped select us, so I'm really proud to represent the bioinnovation, and we have many great things happening in Indiana. So FiberX, as many of you have heard probably, you can make a lot of stuff out of lignin except money. And I'm going to give you a story today that shows that that will be proven to be false because of the work at FiberX and our co-partners at Purdue University. And as a graduate of Indiana University, that's a hard swallow, as some of you might suppose. So, as you know and you've probably heard, everybody in the world is looking for sustainable feedstocks for the chemicals industry. But there are some problems in providing those. And part of it is, everybody works at the science side of it, but as we know, you need lots of biomass material to get the targeted material that you need. For instance, to get the lignin out of corn stover, our feedstock in Indiana, you only get about 17% of the material out of the plant. So in order to be able to use it as a feedstock, you need a lot of material to do it. So you have to have a robust and efficient supply chain, a safe supply chain to do that. And then you have to have a cost-effective means to be able to get the materials out of the plant to use it. So what is FiberX? We are a biomass refining company, but we looked at this in a holistic way that we have to have the supply chain to get the feedstock to come into the refinery, and the refinery has two primary components. The first, in Maryville, Indiana, we have a processing plant where we take a 1,000-pound bale of stover and we turn it into microfibers and fibers of various sizes, all the way down to fiber down to about 100 microns in size right now, and we're targeting to go even further. And those are feedstocks for different industries. My focus today, however, while we can take that and add it into the plastics industry, which we've done successfully, the turf industry, a whole variety of places, even wattles for erosion control we can use corn stover for. But my focus today is on the biorefinery. And what we're doing unique here is that with Dr. Jim Carruthers and Enrico Martinez at Purdue, they developed a sustainable process to use a sustainable feedstock to make sustainable biochemical products and materials. What's interesting here is that we're able to get three co-products out of the lignin. And we're able to get the cellulose, hemicellulose out, but also the lignin, but preserve the chemical integrity of that lignin. And this is what starts to differentiate us. Because as you know, when they make paper and they need to get the fiber, they destroy the chemical value of the lignin. And it can't be used. And all they do is burn it for cogeneration of energy. Well, we do something very differently. So our goal from the start was to have a lignin-first biorefinery where we get the lignin out, preserve its chemical integrity, to then make chemical products and feedstocks out of it and make many of them. And that's why we believe we can make money out of lignin. So the platform. We use supercritical vapor explosion in the presence in a bath of methanol. And we explode this fiber. And we did this through generations of work that had to be done to figure out that this was the great way to do this. And when we do that, we separate out, as I said, the cellulose, hemicellulose, and the lignin. And then we fractionate it. We go through a catalytic process, and we're able to then depolymerize that lignin into derivatives of lignin. And by the way, as we do that, we reduce the variability you expect from biomass products because we're taking it down to monomers derived out of that lignin instead of trying to make products directly out of the lignin, although we could even do that. What Dr. Carruthers had as a vision 10 years ago when we started this was the process also had to be sustainable. So for instance, that methanol we use at the start of the process, we recapture and reuse 100% of it. So we don't have to keep putting solvents and materials in, and what that does is allow us to have both a sustainable process, but a cost-effective process to do this. So why depolymerize lignin? And we love Dr. Najid up at Michigan State. one of the experts in lignin, and she is on record and has published twice that corn stover lignin is the best form of lignin to be a future feedstock. Well, why is that? Because when we extract it, it is chemically reactive and very versatile. And we're able to get a lot of it out. As you can see in this graph, when we push the pressures and the temperatures up, we're able to get about 90% of the lignin out of the corn stover, a very high yield. But what's really exciting about the team at Purdue, what they did is, we've identified over 40 compounds that are in that lignin molecule. And if we change the temperature and pressure and time in the presence of the catalyst, the novel catalyst we use at Purdue, we're able to change and modify the type of lignin derivative that comes out. And that's why we believe that we can make money, because we can make multiple derivatives that become multiple feedstocks to make different products. What have we proven the ability to already do? We've been able to make industrial resin for the fiberboard industry. We're in the process right now with a partner of using a soy product, a soy oil product, along with our depolymerized lignin, and we can make a flexible form of epoxies. As you know, epoxies are generally very brittle. If we can introduce a product that is, I've heard one of the lessons of this meeting, and I was at Change Chemistry last week, you must have equal to or better performance at a comfortable price and be a sustainable product, right? Well, guess what? We can do it. That's what's exciting about FiberX. And so we're able to change the nature of and create these tunable lignin derivatives that come out of the catalytic reaction of the process. The good news is a lot of money can be made at this, because there are 3 co-products that we bring out. We could take those co-products of the cellulose and hemicellulose we've already demonstrated. They can be turned into lignocellulosic ethanol to make, I guess we have to call it now, synthetic aviation fuel. But we think the better place to go is where we can turn the cellulose and hemicellulose into things like hydrogels and other products. And the lignin derivatives we've already shown could be turned into a wide variety of products. And that's why we think a lot of people that are in the booths outside that I've already spoken to are going to be very interested in this kind of technology, because it is such a versatile product. So where are we with the technology? We're very close to achieving TRL5. We're very excited that our Rajdeep, I won't tell you his last name because I don't want you to come and steal him from me. He's a PhD candidate at Purdue. He has saved me $500,000 in budget, because he's completed our mass balance analysis, our TEA, our Aspen modeling, and our LCA. And we've proven that we're positive in all of those regards. And when we complete our engineering plans, we'll achieve TRL5 and move on to build, and we're in the planning stages now, early next year, to start to build out a larger scale demonstration plant to be able to prove that we can do this at some larger scale. I'm fortunate to have 2 fabulous guys running co-jockeys on this thing with me. Wade Lang, most recently, when he retired to join FiberX, was the Chief Entrepreneurial Officer at Purdue University. And Wade's job was to help faculty and students that had big ideas identify if they were commercially viable. And to have Wade and his phenomenal connections and reputation in the State's great. Tom Santelli is one of the most productive new product innovators in America. For instance, one of the things he did as a side project, he eradicated anthrax in the U.S. mail. Tom also built the R&D centers at Great Northern Nakusa, Owens, Illinois, Georgia Pacific, and Weyerhaeuser. All 4, he built all those R&D centers. He has a 90% track record introducing new products to market, and I'm really fortunate to work with both of these gentlemen. So, as my older brother taught me, I would not want to embarrass you by not closing you, so I'm going to make my ask and my close at the end. We are raising money to get us to that next stage so that we can introduce our mechanically derived products, but at the same time get ready to build our demonstration plant for our biorefinery. We are actively beginning to look for a president of our biorefinery. That's not me. I'm an Army veteran. I'm a former college basketball coach. I've got a biology degree. I've been part of 14 startups. I was raised about $150 million in capital for the 14 startups I've been part of. But I'm not a chemist. And we need a great chemist who understands biochemicals and the idea of sustainability in the chemicals industry to lead our effort with the biorefinery. He'll be working with Tom to lead that. We are also looking for technology partners, joint development partners. We are doing small lot samples right now. For instance, as you may know, lignin is naturally a UV protectant material that is now being looked at and evaluated by a major company in the world to be a bio-based UV protectant, because all the sunscreen you use, you're slapping oil all over yourself. How safe is that? No matter who makes it. So we think there are going to be many derivative products out of this material, and we're looking for offtake agreements and partners to allow us to get there. Here's contact information about us. We'd love to have anybody that's looking to partner with us and learn more about the utility of lignin and how it's going to be used to make money in the future. So thank you very much.